Imagine a particle and a particle-sized barrier. Assume that the particle cannot go over or around this barrier. It can also not breach the barrier. And it also can't move the barrier and then travel to the other side. Then how does the particle get to the other side? Based on all of our observations, it seems that the particle actually somehow teleports to the other side. It gets to the other side, but doesn't go through the barrier, over the barrier, around the barrier, and doesn't move the barrier. This is very contradictory to our standard idea of what physics should look like. We've noticed that the chance of it actually making it across the barrier exponentially decreases as the width of the barrier increases. So yes, it is possible that a human could technically quantum tunnel through a wall. It's just not going to happen. Something that makes this paradox very annoying is that a photon won't have any mass, and it travels at a constant speed, which also happens to be the fastest speed in the universe. You'd expect the particle to teleport to the other side at the speed of light, but that'd be incorrect. It actually seems to travel faster than light immediately, which defies the laws of general relativity, which has only been proven, but so has this. So it's very contradictory and confusing to us. We are yet to figure out how we can explain this in the cosmos because it currently doesn't match up our other theories of the universe. You may be asking why quantum tunneling happens in the first place. The answer is we have no idea. To explain quantum tunneling would be to try to explain why gravity exists or anything else in the universe, why things exist instead of not exist. It's just not a question that we can actually solve. As far as quantum entanglement goes, if you had a photon and then for whatever reason it was split in two, those two new photons would have the same exact spin. And no, they are not actually spinning. Spin is a figurative term used to describe a property of particles. The most insane part about quantum entanglement is that if it is observed, the photon is observed, then it will actually send some signal to the other photon faster than light, which makes absolutely no sense with general relativity, and then that other photon will change its spin so that they are no longer identical. It makes no sense. So technically, once you observe one photon, you will immediately know the spin of the other. That concludes our science lesson and this quantum physics series that consists of 2 different episodes. And yeah, goodbye.